Hey there, POE. In this video, we're going to be talking about IMA, AMA, and efficiency specifically for levers. So let's say we've got a first class lever right here. We know that the fulcrum is in between the two. And we're applying a force on one end, our effort force of 16 pounds, that we're trying to overcome that resistance force over on the other side. Now, when talking about ideal mechanical advantage, we're always dealing with distances, but for each simple machine, the distance is going to be a little bit different. So for a lever, the distances we're going to measure are always from the fulcrum. So what I mean by that is if we're trying to calculate our ideal mechanical advantage, to find our effort distance, we're going to start from the fulcrum, right at that spot, and we're going to measure all the way to where that force is actually happening. So this would be our effort distance. Doing the same thing to find the resistance distance, we're going to start at the same spot in the center of the fulcrum, all the way to where our force is acting. So you are always measuring from the fulcrum to wherever your force is happening. So let's say our effort force was to the middle, then our effort distance would be from the fulcrum to that spot. Not too shabby. So that's a pretty easy calculation for us to make. Now the forces don't really depend on the type of simple machine, so those calculations are going to be really, really easy. So let's say we have a situation where we have an effort distance of 5.5 inches. Let's say we have a resistance distance of 2.25 inches. So not too bad. So let's ask ourselves three questions. Let's calculate the IMA, let's calculate the AMA, and let's calculate the efficiency to see how well this machine is actually working for us. So let's start with the AMA. And again, that's a pretty easy calculation since we know that the AMA is the resistance force divided by the effort force. So let's take AMA, and we know the equation is equal to 32 pounds over 16 pounds. Notice that I'm including my units every time I put a number down. And what's really nice is those pounds are on the top and on the bottom, so they just go away. And we're left with a pretty easy calculation of 2. So we have an AMA of 2, and that number is unitless. So that means that we need to provide half as much force in order to get that resistance force move, which you could probably see right from the start. Let's do the same thing for the IMA. Another really simple calculation. So we have our ideal mechanical advantage. And for that calculation, we're talking about our effort distance over our resistance distance. So I'm going to say 5.5 inches over 2.25 inches. And if we type that into our handy dandy calculator, we get a value of roughly 2.44. And again, since we have inches on top, inches on bottom, that number ends up being unitless. So the last thing we have to do is another pretty easy calculation is the efficiency. We're going to see how much energy we're losing to friction or outside forces or things like that. So to find our percent efficiency, we're going to take our AMA divided by our IMA multiplied by 100. Now watch out, because if you come up with a number that is greater than 100%, something's wrong. And more often than not, you just kind of flip-flop those two numbers when you are doing your calculation. So let's do that real quickly. Our AMA is 2, so we say percent efficiency is equal to 2 divided by 2.44 times 100%. Type that bad boy into our handy dandy calculator, and we get around 82% efficiency, which is incredible. And you're going to find when you are actually creating some of these machines, you're going to have really, really, really low efficiencies. But the big takeaways from this video, remember your distances for IMA is always measured from the fulcrum to wherever your force is. And make sure you are paying attention to your efficiency, because you can never, ever, ever have an efficiency bigger than 100%.